So the first thing we're going to look at is the measurement conversions. So with the measurement conversions, we're looking at the base unit. It's also referred to as a fundamental unit. So that's meter, litre, grams, and bytes. Now, if I have a deca, that's going to be 10 lots. Hecto's 100 lots. Kilo is 1,000 lots. And so it goes up. You can see by the power of 10. And deci's a tenth, centis 100, and millis 1,000. So what does this mean? If I put here 100 meters, I'm going to get one. Oh, hang on. Sorry, where am I? If I get 1,000 meters, I'm going to get 1 kilometer. If I've got 1,000 litres, I've got 1 kilolitre. If I've got 1,000 grams, I've got 1 kilogram. If I've got 0.01 of a metre, I've got 1 centimetre. Okay, or 1, if I wanted 1 mil, I'd have to go where am I? Here I've got 1 millimetre is 1,000th of a metre. 1 mil is 1,000th of a litre. Okay, so I'm going to put that back to 1 there. So that you can play with. On the next one, we're looking at the prefixes. So we've got another sheet to play with. And then here, that's like, you can actually change this number. So I could pick any number and it will change. So you can actually play with that to try and solve problems. So I don't want to go any further with that for you guys because it should be revision. If I look at my Google site, it's currently being edited, these are where the milli, the centi, the deci, the kilo come from. If you understand that language, then it makes life a lot easier because you see the connection between the kilobyte, the kilogram, the kiloliter, kilometer. It all makes a whole lot more sense if you can get that overview. So that was the first thing I wanted you to look at. If you are interested, you can actually have a look at Google about base units, and we've got all sorts of information about that. We also have unit conversions. Now, I know most of you can Google how to convert, particularly if it's from imperial to metric. You can do some Googling of that. We've got a little quiz thing which you actually did yesterday, and then a little video. So I want to move on. So that's sort of enough on the whole measurement units because you should have learnt that last year. So what I want to work on today is having a look at these formula. Now the formula for the square, the parallelogram, the trapezium, the rectangle, and the triangle are so connected. And once you get the connection, you know the formula. You don't have to remember them. So how do I see it? Okay, so here, I'll just make sure I'm moving. Here I have got a what? What's that pink shape? Anybody? A rectangle. Okay. Now with this rectangle, I can actually move this. Whoop, move it around a bit. Maybe I shouldn't. Maybe I should just move that back. It's just going to get annoying. All right. I am going to make this rectangle. Whoop. That's okay. This one here, let me see. If I make it 25 square units, how would I do that? Nah, I don't want to do that. 6 6s are 36. How about that? So we'll get that there. I just want to make sure it doesn't slide. I want to get it exactly to 6 by 6. So 6 6s are 36. So we have, what shape is that? A square, thank you. And so it would be base times height, but the base and the height are the same. if I was going to make that 30, if I move that in by that, I've got 30. That's okay, base times height. So everyone's okay with a rectangle being base times height. So we've got 5, another 5, another 5, another 5, another 5, another 5. We've got 6 times 5 is 30. Now this is where the fun begins. I'm going to move that across. Now, theoretically, that should not be changing my area. So I've got something set up not quite right here. There's something not quite. That says 30. And as I'm doing this, it's getting bigger, isn't it? So there's something not quite. I'm suspicious that this is actually not where I want it to be, that I mucked it up. That says 30. Let me see. There we go. So now that's actually going on a parallel line. All right, so what shape is that now? Parallelogram. Thank you. So it's a, well, okay. There we go. Can we see the 30? Yeah, I just need to stop that from moving. And that should be my vertical height. Okay. So we can see that as this goes, what's happening to the perimeter of the shape? The perimeter is going longer. Yeah, the sides are going longer. So the perimeter is changing. The perimeter is getting more and more as the shape gets spread out, but the area is staying the same, so long as that top one here and the bottom one here is parallel. And these two are the same length, and these two are the same length. So we have the area of a parallelogram. Now, just to go back to here, we can see the square we saw base times height. The rectangle base times height, doesn't matter, you can call it width times height or length times width or whatever, but it's this direction times that direction. So we've done the rectangle and the square. The parallelogram, we can see why it's that vertical height. Okay, so if I go back here, you can see that's why I've got the height here. It's that vertical height, not the slant height. That's the one that we need to be using. Okay, so now I'm going to click that and I have got a triangle. What can you tell me about the pink triangle and that kind of blacky grey thing? They are the same area. So if I just make sure I'm not doing it. Yeah. So if I bring it back here, you can see quite clearly that one is half of the other and it still stays half. They've actually got rotational symmetry. You could get the midpoint there and rotate them around. Okay, so therefore, what is the formula for the area of a triangle? That's right. So if we look at our triangle area, it's a half base times height. And here you can see the vertical height, but I feel in my dynamic thing here, the vertical height is quite clear that with this triangle, for example, the height doesn't even fit inside it. It doesn't have to be a right angled triangle, we just need to know the height there. So the last formula that I want to prove is the whole idea of a trapezium. So here I'm going to have two that way, and I'm going to make sure that although they're parallel, I don't have any, there's two different triangles, right? So if I get a segment between here and here, I have two different triangles. Does that make sense? But they both have the same height. So if I go to my formula for the area of a trapezium, you can see half a plus b times height. What we've actually got is two triangles. So we've got, if that was a, we've got base times this height over here, and halve it because it's only half of the parallelogram. And then for this one, we go half this base times that same height. We can use algebra. Oh, once we've got the two different triangles, what we do to the area to get the whole area? we had the area of this triangle and the area of that triangle. You add them, yeah. So if we added them, we actually end up with this formula. A half AH plus a half BH factorizes to that. So what I'm saying to you is, if you get it, you don't really need the formulas for this, 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 or this, or this. So that's 1, 2, 3, 4, 5 formulas that all just focus on base times height and the fact that a triangle is half of a, or half of a, it's not always half of a square, is it? It's always half of the parallelogram, because that can get very peculiar shaped triangles. Okay, sweet. Any questions? Oh, yep. What's the radius? So let's just go here with our lovely GeoGebra. I'll save that so it's not gone. And then we are going to go new. And if we play with this, and we have a look at circles, it says here circle, center, and radius. So I'm going to do that, and radius of 5, for example. And the other way we can do is we can have a segment like so. We can have a circle like so. And actually I can show you something kind of fun. If I go like that and I get that one, I think I can animate it. Whoops, not if I do that. I don't want to do that. Okay, let's make sure we're moving, not constructing. I think I'm moving. Get rid of that one. Right, if I click on this one and I animate it, then that line is my radius. So can you see there that I've got all of the radius? Do I need to colour it for you?
No.
No? Are you sure? If I click on that, then I can colour it red. No, pink. And then the line I can make really fat. Okay. Push play. That is my radius. Now, who wants to know where the diameter is? The whole thing. So for the diameter, we actually, if I grab a line that goes between, say, that one and that one, then the diameter, I make a segment. It's got to go through there and there. So it's got to go through the center. And with that one, should I make the diameter blue and really fat? There we go. There's my diameter. What's the other thing you need to know about circles? Circumference. So the circumference is this bit here. Whoops. This bit here is the circumference. So I want to make that color. Oh, but I don't want it like that. Do I? I want the line really fat. And what color do we want that? It can be green. Blue. Okay. But my diameter seems to have disappeared. Never mind. That's the circumference. What else do you need to know? What's the other thing? What's my favorite? Oh yeah, you can work out it. Perimeter is the circumference. There's a nice thing called a tangent. So here is a tangent. So I think if I go like that, there's my tangent. So push play again. You see my tangent? Isn't my tangent nice? Yeah. It's a nice tangent? Yeah. Very good. Okay. Have you had enough now? Yep. Okay. Done.